All right, advanced math students, this is a little bit of a complicated subject. Drawing a box and whisker plot, not like a normal graph, has some pretty distinct characteristics about it that sometimes can get a little confusing. So pay close attention and be sure to pause the video whenever you need to write something down, make a note, or you have any questions. Put them in your question box. Okay, box and whisker plots. We're going to learn how to display and analyze data. All right, box and whisker plot is the kind of graph that we're going to be working on. Then you have three parts to the graph. If you've ever seen, hang on one second. If you've ever seen a graph that kind of looks like this, something like that, that's a box and whisker plot. Okay, we'll go over these vocabulary words in detail in just a second. All right, a box and whisker plot uses a number line to show the distribution of a set of data. So that's kind of what I just showed you. It kind of looks like a box with whiskers. To make a box and whisker plot, you have to divide your data into 4 equal parts using quartiles or quarters. Sounds like quarters, so remember it that way. 4 equal parts. The median numbers are going to be in your middle quartile, and it divides the data into a lower half and an upper half. The median of the lower half is the lower quartile, and the median of the upper half is the upper quartile. Sorry. Okay, so now we have to figure out how do we actually draw this. All right, now remember, to find the median of a data set with an even number of values, you have to find the mean of the 2 values. Remember that, okay? Find the mean of the 2 middle values. Don't forget to do that. All right, so we're going to use this data to make a box and whisker plot. We have 67, 67, 69, 73, 75, 75, 81, and 85. And we've already done that in my head. Order the data from least to greatest. So let's do that first. 67, 67, 69, 73, 75, 75, 81, and 85. Now we have to, now we have to separate this into quartiles. The least value is 67. The greatest value is 85. So a good way to do that is to do, not that you have to do this, but to do different colors on the 67 and the 85. Now we have to find the median of the whole entire group of numbers. Where is it? Right between 73 and 75. So that is our median, which is 74. Do you kind of see how a box and whisker plot might be developing? Okay, so we divide our data in half at the median. We then look at each half individually, and we find the median of each half and circle it. All right, so apparently something has... Okay, so we lost internet, but we are back. So let's continue with the next part of the problem. Now, we've divided our numbers in between the median, and we've circled the median on both sides of the entire set's median. So the lower quartile, its median is 68. Now the upper quartile, 75 plus 81 divided by 2, is 78. So we now have our lower quartile and our upper quartile. Remember, once we draw the line through the middle of the number set, which is the median of the entire set, we then have to find the median of both halves of the sets. That will give us our lower and our upper quartile. Now we draw a number line and label it to include all of the numbers in our data set. Now, just in case you don't understand, if we started this number line at 0, how long would our number line be? It would be extremely long. So we want to make sure that we're using the range of data, the lowest number and the highest number, to draw a number line that includes all of our numbers, but doesn't have too much extra information. So, above the number line, you're going to plot the points for each value in step 1. Okay? So, now we draw a box from the lower to the upper quartile. Inside the box, we're going to draw a vertical line through the median. Then we're going to draw the whiskers to show the lowest and the greatest values in our data set. Good job. Let me go back so you can study that. Okay, so let's try one ourselves. We're going to order the data from the least to greatest. That should always be our first step when dealing with lists of groups of numbers. Then we need to find its median and the lower and upper quartiles. So we number it from least to greatest. So where is our mean? Where is our median? We count in from each number. So we actually have a median in this one, 31. Good job. Now, now we have our upper and our lower quartiles. Now we need to find the median of each of our quartiles. 22, 24, and 27. What is our median between those numbers? And 35, 38, and 42. 24 is the median, and 38 is the median of our upper quartile. So we have 24 is our lower quartile's median, 38 is our upper quartile's median, and 31 is the entire data set's median. Let's see what that looks like on a number line. Now remember, we use the range and a few numbers past both the least and the greatest of the range to be able to draw a good chart, to be able to draw a good number line that's accurate and will fit all of our information in. So above the number line, we're going to plot a point for each value in step 1. Okay, so I'm pretty sure we had more points than that for all of our values, but this will include our lowest number. This will include our median of the lower quartile. This will include our median of the entire data set. It'll include the median of our upper quartile, and then it'll include the greatest value on that. Those are the 5 numbers you're looking for to be able to graph. So we're going to draw a box from the lower to the upper quartile. And from the lower to the upper quartile, I mean the actual median of the lower and the upper quartile. Then inside the box, we're going to draw a vertical line through the median of the entire set, which is 31. Then we have to draw our whiskers to the least and greatest values to show that it includes all of the data on each side. Now we have our box and whisker plot. Okay, so an example when we're comparing box and whisker plots. We're going to use the box and whisker plots below to answer each question. Which set of heights of players has a greater median? Well, we see that the red basketball players, their median is 74 because it's in the middle of our box. And the blue players, theirs is at 70, which is in the middle of their box. So which is higher? The red basketball players. Good job. Okay, so which players have a greater interquartile range, which means which players have the greatest range? Okay, who has the longer box? Uh-oh. Who has the longer box? Well, the red box goes from 68 to 78, and the blue box goes from 66 to 74, which is only 8. So the red box is the longest. Which group of players has more predictability in their height? Well, the range and interquartile range are smaller for the baseball players, so the height for the baseball players are more predictable. Do you understand why? Because there's not that much difference in between their heights. So you would be able to give a better estimate of a baseball player's height than a basketball player's. For example, the baseball players, their heights only range from 64 to 76 inches, which is only 12 inches. The basketball players, they go from 67 to 85, which is 18 inches. That would be a little bit harder to figure out. Okay, let's try another one. Which shoe store has a greater median? Now remember, the median of the entire data set is what we're talking about, and that's the line with the dot through it inside the box. So the maroon shoe store has a median of 28, and the green shoe store, Sage's shoe store, has a median of 32. So which shoe store has a greater median? The green one, or I'm sorry, Sage's shoe store. Which shoe store has a greater interquartile range? Well, an interquartile range is the box itself. That's what it's talking about. So, maroon shoe store goes from 26 to 36, while Sage's shoe store, and let me show you where I'm talking about. We're looking right here, and here, and here, and here. Oops. Let me erase those. Okay, we're looking here, and here, and here, and here. Very good. Okay, so which shoe store has a greater interquartile range? Well, maroon shoe store goes from 26 to 36, while Sage's shoe store only goes from 26 to 34. So which has the greater interquartile range? Maroon shoe store, because it's got the longer box. Which shoe store appears to be more predictable in the number of shoes sold per week? Now remember, pause your video to be able to work the problems out yourself, because I work straight through. So, which shoe store appears to be more predictable in the number of shoes sold per week? Well, to be predictable, you need to have a smaller range. So which one has the smaller range? Okay? So the range and interquartile range are smaller for Sage's shoe store. So the number of shoes sold per week is more predictable there because the box is smaller and the range is smaller. Very good. Log on to my.hrw.com to take the lesson quiz.